Hey, boys and girls, back for another episode. Today, we're going to be talking about some quick ways that you can just look at a number or do something real quick and then potentially figure out if we can divide that number evenly or if the smaller number is what's called a factor. Okay? So, for instance, if I'm trying to divide a number by 2 or trying to figure out if 2 goes into it, all I have to figure out is it an even number? Okay? 2 goes into any even number. An even number is a regular number that ends in 0, 2, 4, 6, or 8 in the ones place. Once I see that number there, I automatically know that 2 will fit into it. Like when I look at the number 3,482, all I have to look at is my ones place. If that ones place is a 0, a 2, a 4, a 6, or an 8, then 2 has to work. It's an even number. It means there'd be no remainder. Similarly, when I work with 5, what I have to look again is the ending. Does it end in the ones place with a 5 or a 0? And when I come over to the ones place, yes, it does have a 5 there. Okay, so 5 would go into that evenly, or it is a factor. Okay, if I flip that around and do that the other way, if I look at the number 3,482 with 5, it is not going to work. So this would not work for 5. Okay, and similarly, if I flipped it around for 2 with this one, again, that is an odd number 5, which means 2 does not work. There would be a remainder. Okay, so those are kind of quick and easy ways, or I think kind of the easiest two. Again, along with 10, which I didn't put up here, but 10 would just be ends in 0. Okay, so if it ends in 0, it's 2, 5, and 10. And then if it ends in 5, it's 5 and 0. Again, if it's going to work with 2, it's 0, 2, 4, 6, or 8 in the ones place. So with those, you really just have to look and see what's there. For 3 and 9, what you have to do is you have to add all the digits together and then figure out if 3 and 9 work with that. So if I keep those same numbers of 3,482, I would add 3 plus 4, which is 7, plus 8, which is 15, plus 2, which is 17. Okay, 3 does not go into 17, and 9 does not go into 17. Okay, so I would know right away that neither of those is going to work. And then I do the same thing with 9,765. 9 plus 7 is 16, plus 6 is 22, plus 5 is 27. Okay, the number 27 is divisible by 3, and it is divisible by 9. So 3 and 9 are going to work, or there's not going to be a remainder when I divide those into 9,765. When I divided them into 3,482, there would be a remainder. Okay? Same thing here. That's kind of all you're looking for. When we talk about does it go in evenly, or as we talked about with prime and composite the other day, it means there's no remainder left. Okay, 4 and 6 are a little more complicated, so I'm not going to get into that, but your teacher can get into that. But I want to just kind of quickly show you those ones, which I think are kind of the easiest ones to remember. On the back of your worksheet today, essentially something called prime factorization. It's just a fancy way of saying break the number down until you get all prime numbers. So for instance, with 48, one way to break 48 apart that pops in my head quickly is 4 times 12. And that still equals 48. And I just kind of broke 48 apart, kind of like our number bonds that we did the other day. Okay, 4 and 12 aren't prime numbers. I can reduce or change both of those again. Like 12, I can change to 4 times 3. So the 4 kind of stays. Okay, so I'm getting pretty close there. Then I would kind of keep going until I get all prime numbers. 4 I can change again. 4 I can call 2 times 2. Okay. And the 4 and the 3 still stayed. And then again, my other 4 I can also change. Where the 3 stayed, the 4 became 2 times 2. Okay. At that point, with all 2's and 3's, there's no more I can do to change those. Those are all prime numbers. 2 is super, super important. I know I talked about it a lot with my class yesterday. 2 is the only even prime number. Okay? Any other even number, so if I see 4, I see 12, I see 48, those are all even numbers. I know I can chop that in half or divide them by 2. And then I talked to you yesterday, then you want to find that partner. Okay? When I chop 4 in half, the partner is 2. Okay? So now I picked an odd number, so I know 2 is not going to work with this one, at least with this particular number right now. Okay, with 63. Thinking, how can I split up 63? Again, the one that pops in my head quickest is 9 times 7. Okay, I could be all done there if those are both prime numbers, if that would work. Okay, 7 is a prime number, so that one's done. Like over here, once I got to 3, it just stayed as 3 because that's prime. 9, though, is not. 9 can be broken up into 3 times 3. And then the 7 stays. Okay, all those equal 63. Or over here, those all equal 48. If I go back through at the end, then I go through that, right? 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. And then 16 times 3 is 48. Okay, all those just different ways. Same thing here. 3 times 3 gets me back to the 9. Times 7 is 63. If I have a number like 47, and I'm thinking about all my math facts, like how close can I get? Like 7 times 7 is 49. Close, but doesn't quite work. Okay, 6 times 8 is 48. Again, not quite there. Okay, if I was to pull up my multiplication chart, 47 wouldn't be on it anywhere. So even though it's a big number, that number is actually prime. Okay, again, from my look test from before, right, when I look at the number, it doesn't end in 0, 2, 4, 6, or 8. It doesn't, so it's not even, can't divide it by 2. It doesn't end in 0 or 5, so 5 isn't going to work. It doesn't end in 0, so 10's not going to work. Okay, I add them together. 4 plus 7 is 11. That doesn't work for 3, and it doesn't work for 9. Same way that didn't work for 2 or 5 or 10. I try some of my other small odd numbers, like 3 we already did, 5. I can try 7. Again, I got the closest I get was 49. I could try 9. Again, the closest I got was 45. I could try 11, 44. So again, at that point, I'm pretty confident that nothing is going to work. Okay, so 47 is a prime number. You really wouldn't be able to do anything with it. All right, that's kind of our lesson for today. Hopefully that is helpful.